of Tech Diva Consulting, LLC, a consulting company specializing in web development, data analytics, and blockchain. She serves as an IT instructor for Tri-C. She worked for IBM Watson Health as a service delivery manager and a data scientist, if that's not the coolest thing. She's the former principal with Cleveland Heights University Heights School District. She has an MBA, of course, from The Ohio State University and a BS in Integrated Health Studies from Kent State. So these words are where I get thrown off. She's certified in Six Sigma, Lean Six Sigma, that probably makes a difference, software engineering, biomedical informatics, and has over 20 years of combined experience in healthcare, technology, and education industries. And as we all heard at the beginning, if you were here online, is she's launching a vegan ice cream company this fall. So I know you and Amber figure out the slide share, and let's hear from Denise.
Good morning, ladies. Yes, thank you for that wonderful introduction, Jane. I have a very varied background that people tend to realize. So when I tell my story, obviously my path is not extremely linear. I've gone into different fields as things change, and that kind of makes me a really good candidate when it comes to explaining things across different industries and to other people. So I will get started. I'm gonna share my screen. All right, let me get just everything is, there we go.
Beautiful.
All right, so this presentation is understanding blockchain. It's not just for cryptocurrency. And the reason behind the name is that's the first thing people tend to say to me. Oh, you do blockchain? Do you do cryptocurrency? Well, blockchain and cryptocurrency are not the same thing. Cryptocurrency is an application of blockchain. And so I hope to explain a bit more about the fundamentals of blockchain and really showcase how to apply it or when to apply it to your business. So first up is blockchain terminology. As an educator, I try to start with terminology first to get people on the path to understanding. I think that's typically an easy way to begin. So blockchain starts with a form called cryptography. So it's a form of math using numbers and probability theory. Let me just, all right, there we go. That ensures a record cannot be changed or counterfeited by anyone else. So here in the picture, we basically have a simple graphic that kind of shows what happens during cryptography. So basically a sender, it could be anyone, wants to send something. So maybe it's a file, maybe it's money, it could be pretty much anything, it could be a photo, anything. It goes through this process of encryption. And so the encryption is basically to allow for it to be unchanged and not to be seen by anybody else during that particular time. Then it goes through what's considered kind of a cipher. And then the other person that it's trying to get to goes through the decryption process. So basically taking off the encryption to allow to take away from that security and the privacy. And then it goes back to what it originally was, a file, and the receiver can then see it. So basically it's this process of taking information and transforming it so that it is secure and goes to another user. So really kind of big on peer-to-peer sharing is really kind of the process behind blockchain. So here's some other infographics to make it a little more succinct too. So we have in the first graphic, it talks about Bob. He's trying to send basically a text file. You get what's considered a public key. So the key is what you are given, kind of almost like a password. It's a jumble of numbers, letters, and symbols. And basically, it has to be identical mathematically to the person who's trying to get it on the other end if they try to receive it. So that's kind of the way to make sure that it stays secure. You have to have keys that match. It's no different than when you go home and you put your key in the door. If you don't have the right key, you can't open the door to your home. So it's the same thing when it comes to blockchain. It's this idea of keeping things secure and making sure people have the appropriate keys to help with privacy, security, and to allow things to be untampered. And basically the same is happening in the description below. It talks about public key, which I'll get into a little bit more about that, about the difference between public and private. So blockchain terminology as well. So decentralized is a term you will hear a lot, which basically means moving away from storing information in a single place to having information in multiple places. So one of the beauties of blockchain tend to be that it is decentralized, meaning when you have a server, for most companies, when you think of, say, a typical company like your bank, they have typically multiple servers in different places that house your information. Well, blockchain is really based upon the computing power of a bunch of different people's computers. So you can have access to the blockchain on multiple computers to basically support that. But it allows it to be secure because unless you have the appropriate key, you can't access the information. So basically, it's this idea of everything is not in one place. So if someone's computer was potentially hacked or broken into, that does not mean they will have access. They will have the only access to the blockchain. So there still will be a way to have less tampering, the fact that this is in multiple places. Another term is distributed ledger technology, or DLT, sometimes it's called. It's basically the shared log of transactions, which allows a community of users to collaborate without having to trust each other. It allows for transparency, authentication, and auditing. So distributed ledger technology, when you think ledger, I always think accounting or finance, but this idea of being able to track the things that happen between peer-to-peer transactions without needing to have some sort of consensus or some mediator in between. So if I set up, for instance, a contract between myself and another person, I might not know them. I can set it so that the blockchain allows for, once money is exchanged, that they get their product. So this idea of, having fraudulent or people buying things and not necessarily producing what they were selling. I think I had that happen recently. I hadn't been on eBay in a while and I tried to buy something and basically paid for it, but never received the item. So basically this is a way to track those transactions between each other without having to get another mediator in between, for instance, a bank or a government official.
Denise, can I interrupt you?
Yes. I'm sorry, what'd you say?
Let me interrupt you because I figure if I'm not getting this, there might be someone else. So I'm just going to ask a question. When you say, for your example, to track that what's being ordered is being delivered, is this something you implement on your computer while you're doing a transaction?
So yes, implementation happens during the building process of the blockchain. So basically, blockchain comes in different forms. You can have what's considered a smart contract, where basically I use code or technology to type in the stipulations or the rules of what happens in a transaction. So for instance, I can basically say that once I receive said item, money is released, but that will be written in code. So it's a way to kind of have I hate to say fail safe because nothing is truly fail safe. there's always potential for something to happen, but it's a small amount of error here that allows for peer-to-peer transactions. A good example is, for instance, when you buy a car. So you usually go out, you meet someone, if you buy it privately, so as opposed to buying it at a dealership. So you found a car that you're interested in buying, and the person, has to give you the title and all of these other things that need to happen, to be the exchange of ownership in a sense. So basically in code, we would take care of that. So basically the exchange of, okay, I have the physical car now, the keys, the title, money is exchanged, or vice versa. The money has been exchanged. Now I will release, the title, the car, and keys to that extent. So it's basically to help with those peer-to-peer transactions and other things. It's not just peer-to-peer, but it's a way to track. It's a way to have less fraud when it comes to things. It's a way to take out additional fees with intermediaries. So that's kind of the process behind blockchain. But right now, I'm just talking about terminology. I'm going to get into more explanation.
Thank you.
You're welcome. Okay, so here are what's considered the properties of the digital ledger technology. So basically some adjectives or ways to describe it. So it's distributed. So all people who have who are interested or are part of the blockchain have a full copy of the ledger. So it's not just broken up in pieces, and different pieces people have pieces and parts of the information. If you have basically, I'll use the term subscribed, or you have bought into this particular blockchain, all individuals who are part of that blockchain have access or a copy of the transactions that have occurred. It's anonymous, so you don't see demographic information. It's not like how when we go into our bank accounts or we go into our applications, we see, our first name, our last name, our date of birth. That's the usage of the keys. The keys are a way to identify individuals. So that a semblance of numbers, letters, symbols is basically the way to identify. So I can't tell who you are on the other end. I just need to know if you have the appropriate key. Time-stamped. So the idea of not being fraudulent or being able to manipulate or change when transactions occur. Each block as it's changed has a timestamp. It's unanimous. So you go through this process of consensus. That is one of the big things when it comes to blockchain, is consensus of validating of records. So it's not just one person saying this transaction happened. It's a number of people who confirm that this transaction is appropriate or is correct. And I'll talk about that a little bit when it comes to what's considered mining, or individuals who kind of take care of that. It's immutable. The idea of immutable basically is that things cannot be changed, or it's irreversible. Now that is correct, but there are aspects where you can make changes, but it's pretty difficult to do. So if somebody were to make a change, for instance, someone hacked into the blockchain and attempted to make a change, it would alert the rest of the copies of the blockchain to see if that transaction is actually correct. And if it isn't, then obviously, that part of the blockchain will kind of be shut down, and you'd continue with the rest of the copies. So this idea that, if someone tries to enter from somewhere, they don't have access to everything. You have to really try hard to make sure everything matches up mathematically in order to prove transactions and prove who you are to even get access. So security, All records are individually encrypted, so you don't, things are handled kind of in batches. So we'll talk about the idea of the block and the chain, but everything is encrypted and needs to be decrypted in order to be accessed. Programmable, so blockchain is programmable. That's what I just kind of discussed a bit about, how you can set the code to do particular tasks. So if I've paid for a car, or I paid for an item, maybe I bought a book or a painting or a piece of art, I can set it in code that once the exchange happens, to release a certain amount of money into someone's bank account, or to pay them in cryptocurrency if that's to be the case. So smart contracts, another blockchain terminology. It's basically a digital contract, but built using code. So I know we have a lot of lawyers here. So basically, there are legal implications to this clearly, but it's something that is being, I know, done in the legal world, where they're using these contracts between individuals. So basically, it's a way to ensure exchange between parties for items such as money, property, shares, or anything of value, to allow for transparency and no need for a middleman, such as a lawyer or a notary. So I know that there are some lawyers that actually have started learning blockchain and building smart contracts, but they help to define the rules and penalties in the contract the same way that a traditional contract does, but also automatically enforces those obligations. So the idea of not chasing anyone because they haven't made payment or they haven't turned over property, that doesn't happen here with smart contracts. Basically, once the exchange happens, a set of code sets the wheel in motion to say, okay, I've already paid what I need to pay out to receive this property. This property now, either we're going to release documents that state I'm now the new owner, or we're releasing of keys, however, whatever that looks like. Basically, all happens from a code perspective. Obviously, you do get the physical property. It's not digitized property or digitized money necessarily, but basically this happens so that you don't have to have necessarily a bank involved or a lawyer involved. Basically, this is all embedded in the code when you create the smart contract. Okay, so here's a bit about how smart contracts work. So here's a predefined contract. You get the terms established. So just like in any other contract you would do, you'd sit down with both parties and you decide, what is the value of what you're selling, or the exchange of the things that need to happen. So kind of the conditions, and when are they executed? So time and date are all important. So it's the same as in any other contract. Basically, how many payments someone receives. Is it one payment? Is it multiple payments? Is there a rate? Do I need to account for tax? Whatever there is, you can define it in a contract. Then basically it turns into what we consider events. So basically triggers. So as each thing happens, so if it's the exchange of money, if it's the placement of a title, if it's the exchange of shares, it basically has an event for each of those options. And basically, as the information is received or the transaction is initiated, it triggers what needs to happen next. Then you execute and you have the value transfer. So at that point, if the terms of the contract are met and the conditions are met, you'll start the process rolling. So basically, if it's an exchange of money, if it's a title, if it's a house, if it's shares, that will happen during that period of time. And then you have what's considered a settlement. So if it's digital assets, so you can exchange things that are digital. So a book, music, pictures, there are all sorts of things, titles, those types of things can be digitized. And then you have things that are assets that obviously can't be. I can't digitize a home. I can't digitize necessarily artwork unless it is digital artwork that does exist. So that's when those would happen. So if it's actual physical asset that I need to give someone, that exchange would occur. You know, the exchange of keys, things of that. So there's a difference between what's considered an on-chain asset, which basically is something that's digitized, and then an off-chain asset. So that's kind of the aspect of how we put smart contracts together. All right, so just a use case, and I've kind of talked about it as I've been going on. So here are some use cases for smart contracts. If you're buying or selling cars or homes, I know that there are a couple different companies in Cleveland. I know, I believe Bernie Moreno owns one of them, where they've digitized the exchange of titles for cars as a process on the blockchain. So that is a way to utilize blockchain. Marriage and divorce decrees, will and property settlements, insurance claims, and trading and investments. So these are just a couple of ways that smart contracts can be utilized to exchange between peer-to-peer different properties. So here's some additional kind of example use cases. So digital value exchange. If you are using cryptocurrency, you can obviously exchange cryptocurrency. You can have a wallet for your Bitcoin, or if you have your own cryptocurrencies, I'll talk a little bit about that too. If you want to buy something like digital content, so the idea of streaming, a basic smart contract. If you see, it says a landlord remotely locks non-paying tenant out of apartment. Now, I'm sure you guys are aware of things like the Internet of Things and how people are utilizing now digital locks and digitizing things around their home, as far as being able to see their home when they're away with cameras, being able to lock or update like the heat in your home, things you can all do from your smartphone now. So imagine here you have a tenant who hasn't paid for 6 months, and the ability to, you know, hit a switch or basically write in some code that says, you know, in the contract, if you haven't paid for, let's say, 3 months, you know, they could potentially lock you out of your home. Now, I know that doesn't sound great during the pandemic, but it's the aspect of sometimes it's hard to get, you know, tenants out when they haven't paid. You know, we don't want situations like that's going on today, but I mean, it's a reality that sometimes it's very difficult to move people out of a home when they're not paying from a landlord perspective. Here we have a multi-party smart contract, which it allows you to buy a house. So if you had multiple assets, if you had multiple homes or potentially an estate, and you wanted to be able to divvy up your property or assets to different family members, this might be a way to go, is to create a smart contract, so that in the event of, you know, your death, that you don't have the issues that I've seen, especially after my grandma passed last year, when you have to divvy up assets and you don't have a will in place and you don't have things set. So this is a good way, you know, to do that as well. That would be a potential application. Distributed autonomous business unit. So corporations, if they wanted to do shares or monitor payments, that's another way. You can do the same thing with organizations. So deliveries, the local tolls, utilities, things of that nature. The government, I know the government has issued being able to pay your taxes in Bitcoin here in Ohio. You can actually pay in cryptocurrency. So a way to pay your taxes with the government. And then society, if you have things you want to do between other people. So you want to sell something to someone else and come up with a contract. A smart contract could be utilized for that, and in place of a traditional contract. So other blockchain terminology, so Bitcoin. A lot of people hear the term Bitcoin. Bitcoin is basically, it was the first iteration of creating a payment system with blockchain technology, where there was no one in control, no law or no regulations. So this idea of kind of peer consensus, no third party, no intermediaries, being able to be exchanged, being able to determine the value based on what's out in the market. So obviously, because Bitcoin is very finite, it's not infinite, it has a certain level of value. Same thing with other cryptocurrencies. So cryptocurrency in itself is basically, it's a payment network. It's built using blockchain technology. So here are just a couple examples of, some of the cryptocurrencies that exist today, but there are tons of them. So you have Bitcoin, Ethereum, Dogecoin, Dash. I could go on and on all day talking about the different cryptocurrencies. Okay, so after I said all that, with all the different terminology that comes up when it comes to blockchain, what exactly is blockchain? So blockchain, basically, it's a ledger of transactions. I like to akin it to a database. So when you think of a database holds tons of information. I need to have access to it in some form or fashion. But blockchain is a much more secure type of database to have transactions and can do much more than just a standard database, which is really just hold information, extract information, add, create. There's a lot more that can go on what it can hold. So it's a ledger of transactions, which is considered blocks. So that's hence the blockchain. So every time transactions occur, they happen in these blocks. And in order to link to the next transaction, the next block has to mathematically be synced, the cryptography. So basically, hence the blockchain. It's a chain of blocks together. So each number of transactions that have happened need to match up to the next block, which hence creates a chain. So a ledger of transactions, which is similar to a historical log that the bank keeps of all your transactions. But instead of keeping the log only with your bank, many copies are distributed among computers all over the world and automatically updating with every transaction. So it's not just in one place, kind of this singular server way we've done things for a long period of time. It's all over. So let's say my computer got lost. I could still, long as I have my key, I could log in on another computer and be able to download the blockchain again. And my computer, if it was tampered with, you'd know, there'd be an indication. Not saying that the person would be able to get through, but you'd have a clear evidence that someone tried to tamper with the transactions. So every 10 minutes, and that might be less today, it gets faster and faster every time I turn around. All the transactions conducted are verified, they're cleared and stored in a block, which is linked to the preceding block, thus creating a chain. Each block must refer to the previous block to be considered valid. So here we go with the privacy, the aspect of security, the aspect of being unchanged and irreversible. If the transaction previously does not match up to the next block or transaction, then it won't be linked to the chain. So you have to have the blocks basically be able to link up to each other, the transactions. If they don't, then obviously that part of the blockchain would not be accepted, and you'd keep moving forward looking for other transactions that actually do match. So the idea of, think of identity theft. Like right now, you have a lot of people who are, getting unemployment benefits that shouldn't be getting unemployment benefits. You'd be able to verify that with the blockchain. You'd be able to securely say, okay, this individual should not be getting benefits, or be able to verify a transaction if someone took money out of your account. Because I know that happens a lot with our society today. People use other people's cards, even though, obviously you didn't give someone your card, but being able to verify that transaction before it happens. To basically, nowadays the bank sees it, potentially, or you see it, and you have to call, and you have to go through an investigative process. It's pretty long and drawn out, and you're like, okay, well, this is my money. I just want my money back. I don't want to have to go through all this paperwork to get everything that I want back. And it's clear that this wasn't me. This is somebody in, Switzerland or in England making the transaction, or in Idaho, somewhere else. I'm clearly not in Idaho. So things like that, to be able to be extremely more secure and allow them to be corrected pretty quickly, really almost without your knowledge, in a sense. I mean, you'd be able to go in and see it, but not that idea of, I got to go back and I got to figure out where the issue happened. It'd be able to see that seamlessly within the system.
Denise, could we hold on for a second? Because I'm finally grasping a few things here. It took me some time. I'm really smart.
It's okay.
Always been something I don't get. And so what I want to do is I want to stop and see, does anybody have a question on here before we move forward? I hope that this slide and these examples finally help me put information in place, but I don't want anybody lost. And this was a lot of information. Is there any question for anybody so far that you want to ask Denise? Go ahead, Emily.
So us lawyers are going back and forth in chat right now. I'll tell you that right now. Because we're like, why are we even needed anymore? So kind of wanted to get a better understanding of how you can program, legal documents. And so that's something that, we are all concerned about, which is, your divorce decrees, your estate planning documents, your, those kind of things. We're discussing back and forth in the chat about how is that possible, and makes sense that you can program, because the two entities would be actually agreeing to, and then the computer would make sure that you don't have access to that bank account anymore. So that kind of makes sense in that respect, but if you could go through that, that'd be great.
So as far as smart contracts are concerned.
Denise, hold on one second. We do an example of two people in here. So let's say all of us are business owners. So let's say we're hiring Sally to design a new bathroom for us. Could you apply it to us? So let's say, Denise, you are hiring Sally to design a new bathroom for you. Can you walk me through that?
Sure. So so Sally and I sit down, or nowadays we have a virtual meeting. So we have a virtual meeting and we discuss what that contract will entail. She'll give her quote for how many hours, or how much she gets paid for hours. We'll talk about materials, things of that nature. So all the things that you would need to discuss, you still need to discuss outside of the blockchain. But once you get those things, those terms of the contract in place, you would take that contract and then make a digital version of the contract that would then be translated into code. And that's a much more intrusive process than probably I can explain right now, because that requires coding and technology and understanding how to code. But basically, you would turn the contract into code. So I would translate that into a code block. So basically, I'd say, for instance, when Denise releases payment to Sally, Sally, or let's say it's, what do I want to say? It's my first payment towards her. And she feels like, okay, I want to take payment, not necessarily all at once, but you pay basically in increments. So we've decided to pay out for the services over, 4 iterations. So I would write that in code. I'd say, okay, your first payment would be $1,000. Now that you've completed this much of the project, it would be released from my bank account. It'd be shown that she completed this much of the project. Then the next one would trigger. So once she's completed another portion of the project, we'd release another amount of funds. So however we've determined that in the contract, we would just translate that into a code to do the process. So obviously we need to determine, bank accounts, all of that information, the time and date when the money will be released, how much of the project needed to be completed, what happens if she doesn't complete the project, is there a penalty, is there a fee taken away? So all of those things, as you would determine in a contract, you would just translate into code.
Okay, hold on. I know Emily has.
Can I bring something up? Because I have a point. I have a question. So the whole notary, getting rid of the notary and getting rid of the lawyer and getting rid of all that, it makes sense because what you're doing is essentially programming the contract into your bank account systems and into everything that's yours. What if, I'm going to say it, what if you're smart and you go ahead and transfer that banking information and you use different account or you do switch things that are outside of what code can actually do? How do you then do enforceability? Because in our world, the enforceability is the court system, when we breach a contract. So is there a programmable default to when the bank account is empty, when the funding's no longer there, when those kind of situations? I'm thinking about the enforceability aspect of it on the backside when Sally's client doesn't pay her.
Mm-hmm. So basically that's the case. So you're doing all of that in code. So the idea of if that money is not there, if there no exchange is going to happen, it's going to stop. Basically, the computer's going to know. Well, the code is going to know. It's going to know that it's not there. So it's going to stop the exchange. It's not going to continue. So all of that is built out in code. So I'm not going to say you have no need for lawyers, but I think lawyers are getting wind that understanding how these contracts work helps their clients now. This is a great way to not have to do the extra paper trail, to have to get other systems involved. And so you now have a lot of lawyers who are building smart contracts for their clients instead of doing regular contracts.
I have a question. Who's gonna oversee and then release the funds at the different points?
The computer does that.
Pardon?
No, it's programmed into the code. So no,
that's not what I'm talking about. If you're contracted with someone to do work on your house, and you're expecting, like when the materials are delivered, X amount of dollars will be released. How does the computer world know that those products were delivered? Or, once the job is completed, X amount of dollars is released. How does the computer know that the job is actually completed? So you actually have to have a human involved, and don't you have to have human eyes so to see and say, oh yeah, here it is. Okay, completed.
So it's going to depend on the type of transaction. So if we're talking about someone doing payments on a house, that looks very different. So yes, you'll have to have someone involved to say this particularly occurred, but everything doesn't involve physical assets. So that's part of it. So how it will be.
Because I'm the subject matter here, maybe architecture in particular is a very difficult
Bad choice of me, right?
Yeah, nothing, but actually a really great example because it may show the shortcomings. Because unless somebody, first of all, hopefully I would stay on schedule, but life happens. But once construction begins and I am required to review on commercial projects, review invoices to make sure that the work that is claimed to have been completed has in fact been completed before the client has to release the money. This is a particularly complex system that doesn't run on a schedule. If it's paying your monthly mortgage and releasing the monies, that seems to me to be a pretty regular event. But in any kind of transaction where human beings are involved and schedules cannot be guaranteed, the workers are there, everybody's ready to go, and there was a shipment delay. I mean, there's just so many variables. It seems to me that it's just a little bit more difficult, or maybe a lot more difficult in some instances than others.
Right, I should have picked a very simple one so that we could all understand it a little more. And Sally, you raised a good point, but I know Rochelle has had her hand up waiting to ask a follow-up question. Hang on, Denise.
Sure.
I was actually just going to say pretty much what Sally said. How does it work in a service type of contract? Because maybe I'm getting landscaping done, which my landscapers just showed up. I didn't know they were coming today to plant trees. How do I know, do I have to physically report that they installed the trees, they planted the trees, and then the payment goes through the system? I mean, does it require me to take that step, that that part of the service was completed?
Or is it like when the UPS guy delivers a package and he scans it into his little machine?
So it can be applied in different things. There's no one answer. So let me put it that way. Blockchain is applied to multiple different industries in different areas. And this is still a very emerging technology. So I don't have all the answers for your particular industries, because obviously that's not the industry that I particularly work in as far as applying. But what I will say, it just will depend on how you typically verify those particular things. It depends on what it is that the contract is being based on. No, blockchain may not apply particularly to your industry at this time. There are a lot of things that need to be put in place, but it's being used across multiple industries, healthcare, media, a bunch of different places. Like I said, people are using this with exchange of titles. So I can't necessarily answer every single question because that's more of an intricate kind of consulting situation of when you get ready to build. Mm-hmm. And I'm not familiar with every single industry.
I think we can break it down because basically it is agree on contract terms, mm-hmm. whether I'm buying a hamburger or vegan ice cream, but I'm agreeing on contract terms.
Yes.
Someone, not a lawyer, needs to somehow implement this. So what I hear you saying is we're leaving lawyers and going to coding people.
Not necessarily. So your lawyer may become the coder.
But
do you understand?
We need a third party.
So the lawyer may become the person who actually puts the smart contract into place because they have the legalese, they know the background of what this requires in order to build out the contract. So I do know some lawyers who have taken up coding and learned how to do smart contracts and become blockchain developers in order to put this in place.
I mean, it sounds to me like right now, like if you're on the internet and Susie Q's selling a recipe book on keto diet and it says pay $9. So you put in your information and it hits send and then it almost immediately releases the book to you. That's what blockchain sounds like to me.
Well, that's more of just transactions.
Okay.
So blockchain is not just transactions. So as I was stating, blockchain, it's a framework, it's a type of technology to create more security around what happens. But that could be anything. It doesn't have to necessarily be, it doesn't have to necessarily be a transaction. So that's the other piece. Blockchain in this sense, it's a ledger. It can be cryptocurrency. So cryptocurrency can also be what's considered tokenomics. So it's different applications. That's just one facet when we talk about the exchange of value between different individuals. The technology itself, liken it more to a database that has more extreme functioning between the different things.
I have a question. I heard that blockchain technology was going to be used in hospital settings so they can transfer patient information. Do you know anything about that?
I do know about healthcare because healthcare is my background.
Okay.
I do know that for a long time, we've tried to create what's considered unique identifiers across healthcare systems. So the situation behind that is where a lot of people, what they want to do is, let's say I live in Ohio, but then I'm traveling and I'm in Florida or I'm in California and I need my patient records released. We don't want to have necessarily a whole paper trail and I got to call an office. You'd be able to have potentially patients could have their own healthcare records that they could release to their doctors on their own via a special key. It applies in different ways. Blockchain is being used in other healthcare settings when it comes to supply chain. So it just depends on the application, but that's one that I do know of. The idea of patients holding their own records and not relying on the hospitals, if you've lived different places or been a part of different hospital systems, to have to gather all that information. You'd have one complete record that you'd be able to distribute.
Can we apply that
sorry.
slightly easier? Like, let's say we're on my chart or UH and I have my records. Are you saying instead of UH, the clinic holding them, I can hold them on my own?
Because that is your own personal data. So this gets into the conversation of data and how data is being utilized. Right now, the hospitals basically, particularly, I guess you could say they own your data when it comes to your healthcare, even though you're accessing it on their system. But the problem with that is, what happens is, like I said, when you go to a different hospital system, now I have to rely on this entity to give me all the information. And potentially, if I've been seen by different doctors, if I've been seen at different hospitals, if I've been seen in another part of the country, that may not be a completely succinct record. But you yourself could begin to keep your own patient records and have your own kind of personal blockchain with all your patient records to be able to distribute wherever you go across the country, across the world.
Right. Hang on one second.
Have issues.
Rosie, I interrupted you. Rosie, did you have a different question on that? I didn't mean to interrupt. I'm sorry.
Oh, no, that was a good question. Mike, do you know of any hospitals that are currently using this technology?
I can't say that I do. There are a lot of hospitals that's doing a lot of different things. That would be a research.
Yeah, because that just happened last night to my brother. He was seen at say Hammett Hospital, but for whatever reason, his daughter took him to St. Vincent's. And now the people at St. Vincent's have none of his medical records.
Correct.
So I'm more interested in seeing that progress because it could be a potential lifesaver.
I would say, like I said, blockchain is being applied in many different industries and still because it's emerging, but that's one that I do know of that there's been conversation around and research done, and certain hospitals may be looking into it, but I'm sure, as you know, healthcare tends to be behind the times sometimes when it comes to certain things, and to relinquish that type of ownership, I think they'll have to be more involved. But I think that's more of it's a patient rights issue that we've encountered
Right.
kind of repeatedly when you go to different hospital systems, of not having enough information on the patient and having to wait when you need to act. So the ability to prevent, you know, people being given things that they're allergic to, that they might not know that's in their chart, or knowing where they've had a surgery before, you know, trying to keep all that information in your head and write it down every single time is not useful.
Can we go to a simpler, it might be simpler request on this. When you were talking, it made me think about iTunes. So for estate planning, which is what I do, if my kids have put in hundreds of dollars worth of money to buy music on iTunes, they actually don't own it.
Right.
You can't take it with them. So when they die, it goes. It's just basically you're leasing it. You don't
It's a
own
subscription.
it. Is it the same thing? So if it was a blockchain for iTunes, then I would actually own that music and iTunes wouldn't take it away from me. Like I could give it to someone else.
Potentially. So I guess think of it this way. iTunes would no longer be an intermediary. You'd buy music directly from the creators, the content creators. So the musicians, and they could definitely sell you a piece of, you know, their music and sell it multiple times, and you own it.
The musicians, all artists, they could knock it out and actually get money. That would be nice.
So it would go back to that kind of system. So a way to kind of be able to own, because I know a lot of artists, if you think about, a lot of artists don't own their music anymore. But a lot of artists have become independent, where they're independent of large entities. But in this day and age, you have a lot of these intermediaries like Spotify, iTunes, different entities that are basically selling your music on a subscription-based service, and you're getting pennies, you know, as opposed to, you know, you potentially selling your own music. And I do know there are examples of artists, not necessarily music artists, but other types of art, where they've done that. They've created their own blockchain to distribute their work.
So ladies on here, we have about 10 minutes left. And for instance, I know Juliet knows about blockchain ahead of time. There might be other women on here who have a question that has to do with blockchain. And Denise, I know you have a few more slides. So I just wanted to see what everyone wanted to do here. Okay, no one has any questions? All right, Denise, do you have, I know you've heard what we're interested in, so I don't know what you have, but you take it. You got 5 minutes, and then I'll come back to everybody again.
Okay.
Thanks so much for the break. I think it really helped.
No problem, no problem. This is, I always say as an educator, it takes multiple times to hear this information to be able to dissect it. This is not a simple concept. So in no way by means do I think that people would listen and think they're going to get it on the first time. So
I'm actually hopeful. I really thought maybe
yeah, it takes additional explanation and a lot of examples to help people to see that this is a viable technology that could be useful for them. So basically, I kind of already talked about the things that are left on this slide, the time stamping, exchanging. Everybody would have their own copy, and it have to be 100% verified. So you can't have a part of the blockchain that's not verified. That wouldn't work. What we have is what's called miners, people who help to keep up the blockchains. There are people on a regular basis who are mining these transactions to make sure that they link up appropriately. So instead of relying on a bank to verify the transactions, it would be a peer network of people to make sure that transactions are correct. Okay, so just the infographic of how blockchain works, but basically you have data or transactions in a block. It's what's considered, it's labeled by a hash. So you could say like its own little private key or code, and it needs to link up to the previous hash. So that's how they link together. So if it doesn't link to the previous hash, then it wouldn't be a piece of the blockchain. That's how we get them chained together. So hence the name blockchain. So different types of blockchains. You have what's considered public blockchains. That's where pretty much anyone can have access. So Bitcoin, Ethereum, Litecoin. Then you can have what's considered a private blockchain for companies internally, where their transactions are happening. So you would not be able to have a part or be a piece of that blockchain. So there's a way to create a level of privacy if an organization or a company wanted to utilize blockchain themselves. So you have, like I said, what's considered public. So public blockchains basically allow pretty much anyone to have access. And then you can have what's considered a private blockchain, where you limit who can have access to the blockchain and who can kind of mine and do all of those issues. So, or do all of those things. So distributed ledger technology I talked about before, and kind of internet of blockchain. So they're kind of all over. You also have what's considered federated blockchains too. You don't have as many of those around, but basically these are within systems. So within the government could have a blockchain, or a company, or a particular industry. So here's kind of my thought process for the criteria for a blockchain, things that you need. You need consensus. So you need to have this peer network to be able to validate transactions. You need to have a provenance, immutability, and finality. So when these things happen, the idea of changing something midstream, you know, you got to go back and make sure it's accurate on each block. So with the smart contract application, you would need to change that ahead of time, obviously, before, if you needed to make a change. So you want to try to get things kind of concrete before they happen. So I always have this thing to help people understand if they need to use blockchain. It's this kind of my way of determining whether you just need more of a database or actually using blockchain. So do multiple parties share the data? If no, so if you're not trying to share between different people, you can just use a private database. So think of Azure or Microsoft SQL Server or things of that nature. If you have multiple parties who kind of manipulate the same data, so they're making changes, they're transforming, they have transactions going back and forth, and I would say much more dynamic data. If no, you can use what's considered a distributed database, which means that it's in multiple places. Think of cloud kind of in that sense, the cloud technologies where it's available anywhere, but it's still a database. It doesn't necessarily code to do transactions, but it just really holds the information. If multiple parties do manipulate the same data, are there third parties that everyone can agree to trust? So if there are, do those multiple third parties need to update the shared data? If they don't need to have update rights or change rights, you just use a distributed database. But if they need to be able to make changes to the information, you need to ask, is there a requirement for verification? If there is a requirement, can intermediaries be removed, reducing cost and complexity? So this goes back to the kind of the architecture piece. If you can't remove intermediaries, then it may not be best to use blockchain or apply blockchain to that particular industry. But if you can, which will reduce cost and complexity, then you would try to use blockchain distributed ledger technology. If there is a requirement for verification, so no, if the parties can agree on who, how, when data can be updated or used. If yes, use a distributed database. If no, we go back to the intermediary question. Do I need an intermediate to decide when things can be updated or used? And that'll determine whether to use distributed ledger technology or blockchain. So this is one of I think the best infographics when it comes to businesses, because people say, oh, well, how can I apply blockchain to my business? You may not need to apply blockchain. It's not for everyone at this time. There's different ways to implement it. There's different ways to utilize it. You may just need a database, and that may be all you need at this time. And that's okay. You know, but for those who are interested in applying blockchain technology, these are some of the questions you can start asking yourself, and kind of this diagram to determine if it would be best to apply.
Denise, this is a perfect place to bring it around because I get database, and I love that you said these are the kinds of questions you could ask yourself. Is there a woman on the call right now who does not have 100 questions in their head? Figure these things out. What you made me, and I don't know if anyone here is my age or older, but when you said building the blockchains and what you needed to do, it made me think of my Fortran class when I had all of my Fortran cards, and I had to have them in the right order for this to work. On it. So this was an awful lot. The ladies had a lot of information going on in the chat. Denise, I can't thank you enough for, this is more than my coffee. I mean, it's gotten my brain